Okay, let's start. So, in my opinion, going back home from conferences, it's not always easy. You're excited and you should. You have just learned a lot of new stuff and you can't wait to start to use it. But then reality breaks your enthusiasm. You realize that you are unable to rewrite whole your solution to JDD. You will not introduce event sourcing by yourself. You will not write tests by yourself in the whole system, etc. But what if somebody will give you advices that you can use right away, no matter how complicated, old, and tangled is your code? I will try to do it. My name is Marcin Haręza. I'm quite experienced developer. I'm working for Big Picture about 6 years. I like every buzzword growing around software engineering, like OP, DDD, TDD, machine learning, etc. In the free time, I do some sports, usually related to cycling. I used to rock climbing, and I like to read books like science fiction books, fantasy books, philosophy books, but any book will do. But let's get back to the work. I need to explain myself. I don't think that talks about all the things I have mentioned, like DDD, TDD, event sourcing, and for example, microservices are bad. They are great. They broaden horizons and they are priceless. Like especially for development of your skills. Like if such tags will not exist, we will not develop as a community. So they're really important, but sometimes I like to think about today, not tomorrow. Okay, we'll start from collections. And I think that not the very best code is driven by some fears, or better name it, by wrong habits. And one of them, in my opinion, is fear of making new objects, or habit of using as many already created code, already developed code as we can, which in most cases is great habit. Like you don't want to repeat yourself, but sometimes I think we are mixing reuse with overuse. And I will try to show it on a small example. I will introduce you to a sample domain. Probably if you are working in a Scrum environment, you probably know the names like teams and boards. And we've got the boards like a Scrum board or a Kanban board where on a single board, multiple teams are having their tasks and they are planning these tasks and they have a capacity velocity, etc., etc. And the very important fact is that one team can work for multiple boards. So for example, as team alpha, I can work in board 1 and board 2. And we want to make the team repository to return all teams for a set of boards or all teams for a single board. And as every developer from Java world, we use the most common type list. I think it's almost every time somebody is using lists when he's starting such an interface. So we will make a really brief and quick walk around this usages of that code because it's not really important what are the really in the details what we are doing. The first thing is that we want to calculate some alternate scenario. We just want to calculate some really important for teams, sometimes for single boards, sometimes for multiple boards. And a developer is taking advantage of that we have a list. So if you want to replace the team one by another, so he's using that index up functionality and the set functionality because it is a list. Then he's making the implementation for a board. There is a problem because there can be multiple teams. It can be duplicated because one team can work in multiple boards. We don't really know how that interface works because we don't have any Java command, Java docs, because we should make a code that is documenting itself. So we are using replace all, and then we are making a hash set because we don't want to calculate something twice. Okay, it's quite easy. Then we have another usage that is just calculating a capacity, but only for teams that that have some members. And we have the other method, and that we were talking about. There is some report, the same. We need only teams with members. There are some services that are looking for a particular team by ID. So it's taking teams in single board, then it's filtering by ID, etc. We've got some querying service that is querying by name or a member name. So we've got a lot of stream code again. We've got some reporting that we need to have teams with members and teams without members. You want to sort them by some case insensitive order. The same here, but it's quite different because we want just teams in the form of DTOs, etc., etc. And what we see here, in my opinion, is a lot of duplicated code because we are doing the same thing multiple times. There is a lot of stream-related code, and it's not a code really about modifying collections, but there is a lot of stream code there. And there is one problem that we are really bonding with list API. Someone is using the sort method, someone is using the index of method, and we even don't know, some users don't know if there are duplicates or not. And what's more, if we want to change that interface, for example, make a set here. Okay, I've got some problems with ID. So if we will try to make a set here, it will be not possible because if we will try to make a set here, it will tell us that you don't have a sort method on a set, you don't have index of method on the set, you don't have a set method on the set. So we will have a lot of problems. And I've got a solution for it, and I want to show you what is my solution. I really like to make wrappers for collections. And you've got a wrapper that is returning teams or teams of multiple boards. Sorry for that. Yeah, and you've got teams for multiple boards, and you are trying to put these functionalities like order by name, and getting teams with members, getting teams without members. Maybe you want to provide a stream, and you want to make a searching for a name, returning collection with replaced team, and finding by ID, etc. here. And if we look at the usages of these methods, they are way easier than before. We get rid of many duplicates. In some cases, we get rid of many stream calls and many stream trains. Maybe not all of this, but a lot. And the code looks better, in my opinion. And there are multiple things that we can do which were impossible before. Like, for example, we've got the teams, and we've got a lot of finding by ID. And we want to make it faster. And it will be hard for us to do it with a simple list, because we will always need to filter piece by piece, element by element, or we will need to return a map. Here, we can just make that map as a backing collection for that wrapper. So it's giving us more options. I will try to sum up the pros and the cons of such code. For Java util collections, it's good that we have well-known API. Probably we are writing less code because we don't write wrappers, and it's compatible with external libraries. So if you want to use some methods from external libraries with such a wrapper, we'll always need to remap it or convert it to a real collection. From the other perspective, we've got a lot of code duplication. So we're using the same, we are sorting multiple times, etc. We've got no explicit information about order or duplicates. We can use, for example, tree set or sorted set, but yeah, tree set is implementation. But still, in many other cases, it will be hard for us to tell user what is really there. Mutability problems, as you've got the list, you never know if that list is a copy of a list that is residing somewhere in storage, or it's just a copy that you can modify. So if you modify, you are sometimes scared that there will be some side effects. And we've got that refactoring problems because we are bound to API of the Java util collections. And for wrapper, of course, we've got a lot of more pros because I was really motivated to prove my point. So we've got meaningful naming. We can make a good name for a class and make a really good and informative name for a method. We've got the code related to collections, mostly in one place. We've got easy mutability handling. It is easier to refactor because we are giving users, we are providing users with only as many functionalities as we want. We've got less duplication and it's overloading friendly. You can't write the same method with the same name for a list of apples and a list of pears. You just can't because for Java, it's only a list. And maybe there is more code, but I don't think so. And there is a danger of accidental duplication, which is really important. Sometimes we want to put as many methods in that wrapper as possible, a lot of. And then we've got that problem that its wrapper have too much knowledge, sometimes more than he can contain. For example, we've got two clients that want to calculate that capacity. And with the first client, we were so eager to put that capacity calculator inside that wrapper that we did it. And then there is a second one, but maybe his method of calculating this capacity is different, but we want to use that method anyway. So there are two options. We will put some strange booleans like calculate for, is it calculation for a client A or calculation for client B? It's not good. And maybe if we don't have automation tests, we will just fix one bug by another. So accidental duplication is such a situation that you think that something is duplicated code, but it's really not. But still you are trying to make that code in the single place. And so one really important thing with making these collections wrappers with using is that you need to remember where are logic boundaries and how much your wrapper should know. Okay, this is all about this collection wrappers. And we are going further. The other problem that I sometimes see is with inheritance. And I drew some table for an inheritance, which for me is really important. There are usually two types of inheritance. One, when we know that the number of subclasses is fixed. For example, we've got boards. We've got Scrum board and Kanban board, and we don't expect that anybody will add a new board in like really close future. And yeah, for example, yeah, we can imagine a lot of such a limited spaces. And the other is when the number of subclasses is unknown. For example, if you are developing a framework like Spring, you have no chance to know how many, before you run the code, you have no chance to know how many, for example, Beam post-processor are implemented there. It's just impossible. And when number of subclasses is fixed, we know that what usually changes is functionalities. So maybe some methods in the interface are implemented differently, and maybe we will add some method to interface. So as we know what will change, mostly we want to make, the goal of our design is to make that developing new functionalities as easy as possible. From the other hand, when the number of subclasses is unknown, what usually changes is number of subclasses. The more subclasses we have, the more functionalities our software has. And then the design goal is to make developing of such a new subclasses as easy as possible. So maybe, yeah, and the problem I see usually when I make code review, etc., I see that developers don't want to admit that maybe their inheritance space is limited, or they don't know where they are on in this table at all. And it's good to know what are we doing with. I will try to show you it on example. Okay, I will need to introduce the domain again. We've got something we call a goal. And if you work in a Scrum teams, you probably know that in the sprint, you've got some number of tasks. And then you have something that we call goals. So there are developers, and one developer has 3 tasks to do, the other has 5, the other has 3, and we've got a number of tasks, but we want to summarize it. And the goal is such a summary. We can have like 2 goals. So for example, all of us make like 5 different stories, but our goal is to make some module faster, or making 3 stories will make something possible. And that's a goal. And we've got 2 types of goals, and only 2 types of goals. The one is handwritten goal, that you are just writing by your hand. For example, number of bugs will be smaller than. And task-based goal. You see that there is a task that is a goal by itself. So maybe in the list of the tasks that Teams is developing, I can find a task and said, that's a goal. Okay, so goal got ID, it has a value, because we need to know which goals are more important than the others. There is an owner, because we need to know who will be blamed if the goal will be not accomplished. And we've got the status to know if the goal was finished or not. And with that goal, we've got this task-based goal. As we said, is based on a task, so it's got a task ID inside, and there is a handwritten goal, and it got the name inside. And the other stuff is just driven by abstract class, so value, owner, status, etc. And we've got some usages, and one is goal storage. As I showed you, that internal structure of these goals is different between subclasses. We want to store it in different tables. So we are taking this our goal and checking an instance of is task-based goal. We use that helper variable, and we use it to overload method. The same we do here. That's the storage part. We've got the export, because we want to export our goals to a spreadsheet. And we just taking this goal, we're checking if instance of task-based goal. If so, we are finding a task from task repository, and we are taking the name of the task. If goal is handwritten, we are just taking this name that we have written by ourselves. And similar situation, but even complicated, is when we are trying to make goal resource and you want to convert goals to DTOs. And it's really frustrating that we need to make different subclasses, because simple handwritten goal is just having a name, and task-based goal is having whole task DTO inside. And it's frustrating because we have repeated this strange structure a number of times. And sometimes when the function needs to return something, we need to put that fictional illegal argument exception that maybe you have provided the class that I don't know. Probably it will never happen. Of course, there are 2 alternate solutions. One is the polymorphism, just to put everything in a method that will override differently in different classes. It's great usually, but sometimes it's got a lot of sometimes it's not good. Here we will mix concepts from different layers and functionalities into the domain object. So it will be not a good idea. The code will be just tangling concepts and layers. The other is to make separate paths. Like maybe we should have another resource for handwritten ones and another resource for task-based goals. Maybe it would be a good idea, but if we will imagine that we've got like 100 functionalities, so with 2 subclasses, we've got like 200 REST endpoints, and we thought that we will never add this class, but maybe there will be a day in the future that we will need to add another one, and then we will be forced to implement like 100 other methods. So it will be not good too. But I've got another solution. Maybe it will be you'll find it helpful. I like to use in such a cases this notorious visitor pattern that nobody likes, and usually it's like it has this badge, don't use it. And to make a visitor, it's really easy. First, you need to make an interface that is called visitor, and it has, in my case, visit method for every concrete, so non-abstract subclass of a goal class, goal interface. And then you need to implement that method in every subclass. And you are implementing it really easy, just giving it this. And it will work. The correct method will be called because task-based goal know that this is of class task-based goal. If we will try to add such a functionality here, like visitor visit this, the compilator don't know what to do because this is of instance of abstract goal, and that's all all compilator knows now. So we always need to implement it in every concrete subclass, every subclass from interface, visitor interface, and then look how, in my opinion, nicer is to implement these methods. The first thing is that you don't have that instance of call, and from my point of view, the most important thing is that I know what I need to implement, because when I make something like this, the IDE will guide me which method I need to implement. If I will try to make it like before, like have if goal instance of, I will always need to remember how many instances of goal I have. And if ever in the future somebody will add new class, every usage of instance of will we will not know how many places we need to change. Here, if I will add another method, IDE will tell me that I have IDE. The compilator will tell me that it's unable to compile that code because not every implementation implements all abstract methods. And in my opinion, it's really it's a way better option than we have before with instance ofs. And we are getting rid of that illegal argument exception that was thrown, which I really don't like, that fictional exception. So as we say, when we've got fixed number of subclasses and we usually think about developing of new functionalities as easy as possible, we can use visitor pattern. Of course, only if normal polymorphism is not enough. So usually when in different layers, implementations vary between subclasses. From the other point of view, we've got that number of subclasses which is unknown, and I will show how can you help yourself there. Give me a second. Yes. So, for example, you've got that application that is about scheduling tasks. So, user has that user interface. He's got some tasks to schedule, and he's like providing these tasks that he wants to schedule. He's selecting from single select list one of the schedulers. He puts some configuration to that scheduler, clicking OK, and bang, he's got tasks scheduled like in the best processors. Like, for example, he's got like 4 processors and number of tasks that have some relations, and the scheduler will do all the job. And we want to make different implementations because more implementations of schedulers we will have, the better our software will be. So we want to give user points when he can provide a new scheduler. So, for example, he need to implement scheduler factory to create instance of a scheduler, and it need to give it type ID and have a create instance method. We need to implement metadata provider to know what is the name and description of the scheduler to have something which we want to display on user interface. We need to have configuration repository to store the configuration that user have set on the UI, and we need to have converter because UI will vary between this scheduler configuration schedulers, and maybe this object will be different. So we need to have storage to store that rich object and to return this JSON string to frontend. And it's not so bad. It's easy to implement it. I have implemented round-robin scheduler here, and it's good. I've implemented all the interfaces, and when I will, for example, run it in the Spring framework, everything will be fine. But there is a single problem that I don't like when somebody will give me such a API. I don't know what to implement because I need to remember that there are these 4 things like factory, repository, converter, metadata provider, and maybe there is a better way. And a colleague of mine gave me it once as a code review when I implemented something like this, and I call it single point of implementation. I don't know how he named it. You are just making a single interface that is returning every instance of that services that that you needed to implement to provide a new scheduler. And it's pretty good because the IDE will guide you through this implementation. If you will not leave it by yourself, return null, you will know that everything was implemented. So if you try to implement return metadata repository, you will be obliged to implement it. The same with factory, configuration repository, and with configuration converter. It's quite easy. Okay. So as I said, the solution for such cases is to use single point of implementation, and which is nice with both solutions, visitor pattern and single point of implementation, that they have a lot of support from your developing environment, like IntelliJ IDEA or IDEA, or if you use Eclipse or something. The IDE will just guide you through the process, and there will be nothing to forget because everything will be partly done for you by your IDE. Okay. Okay, the last one, but not least, is the untangling concepts. And the thing that I usually see is that we like to make a lot of things in single methods. we like to tangle concepts because we don't, okay, maybe I don't like to create new objects. Of course, I know it's bad, and I'm always fighting with myself to create new object, but usually if I can do something in existing object, I feel so great that I don't repeat anything. And it's the same fear that was driving this collection case. So I will give you an example, and I will ask you to use your imagination because this concept will be really abstract. So we've got action service, and you can try to change the names of the things that I will describe in next steps to anything that you've got in your own system. There is an action. We want to run action. We want to perform it. So we are giving the request, and that request has the object ID and data. So the action will be, for example, is some calculation. It will be performed on that object, taking that data. And for example, it's really hard calculation here, doing a lot of stuff with that object and the data and giving some result. But as it's so complicated process, and it's it has a lot of different, maybe non-functional requirements, we want to measure how long it will take to perform that, that action. So we are measuring the time. Probably we'll have some better methods like stopwatch or something, but maybe we'll do it in the plain Java, and then we will try to log it. We need to change if action is not disabled. Maybe in some configuration, that action is disabled for that object. Okay. Maybe we need to check a security if user have permissions or privileges to do anything on that object. Okay, we are checking that security, and if it will, if we don't have any privileges to do it, it will raise an exception. And where is the problem? The problem is that there is like maybe like 12 or something lines in this code, and there is only one that is focused on performing that action. The most of the function is taking our focus in every other direction. And probably in some coming days, there will be a new concept that will be put here to even tangle it more. And I don't think it's a good code. And I've got some recipes how to make it better, how to refactor it in better way. Okay, we have that action service, and first step that we do is that we are using a factory to create action object that we can perform. I will tell why it's like this, but for the sake of current moment, just assume that it's good. So this action is some kind of probably command design pattern. And what's happening here in that factory? We are creating a row action, and we've got two types of row action. One is null action. If the action is not available, because availability service said so, we will return null action instance. That is a null object pattern, if I remember correctly, and it's always returning optional empty result. Nothing is calculated. If not, so the action is available, we are making action implementation, which is only focused on calculation. There is nothing else than this calculation, only this. So we're taking the object, and we are performing the really hard calculation of that object with that data. Okay, so what has left is security. So we are making a security proxy, or probably security proxy, that is taking that original action, this row action that was here, taking that row action, wrapping it. It's implementing the same interface, and it's only delegating, sorry for that, it delegates that method to the original action, to the delegate, but only after checking the privileges. Okay, so it's separated, like security is separated here from any other concept. And we've got that logging action that is taking that delegate. So it's another wrapper, and we are logging the time of calculation, so of performing that action. And as we see, logging is totally separate from any other concept. What's more, for example, this action is idempotent, and it's really hard to calculate it. So with such a factory and comment object, we can make a caching proxy probably, or maybe decorator. It depends. Maybe we can have discussion about it. And we've got that result that is null. If it's null, we will perform it. If not, we will return it. So it will be calculated only once. So it gives us another possibility to make that code even faster or better, etc. And as we see, all the concepts like calculation, logging, early return, security, etc., was separated. Of course, there are some drawbacks in this code. For example, it sounds like some of business logic is leaking into the factory. To be honest, I mostly did it because I wanted to show that null object pattern, and I wanted to make it in one example, not multiple examples for multi-patterns. There is a lot in this factory that is happening, a lot, maybe even more than in the original method. But in my opinion, it's better to find a place when such things happen, when I will have maybe more mess, maybe they will be a bit more complicated when I create the object, to have that core functionality separated. To when I'm dealing with calculations, I want to have it easy testable and to be able to focus only on that calculation or that action or the business rules of that action, not about logging and, for example, security and caching. So for me, it's better to make a bit of mess here and have a really good view on the other things. I will sum it a bit. Okay, so we've got this untangling concepts. Example, when we use a factory method to use to make detection, comment pattern that was that action, null object pattern for a null action, and we've got some decorators and proxies like caching action, secured action, logging action. Of course, every of these patterns is usable separately, can be used separately. So, of course, I grouped it in single place to make this example simple, but you can use it separately. Of course, you don't have to use them all, and I don't ask you to. Factory will, in my opinion, will always help you to keep some math, some ethology, etc., in one place, and give you a chance to have this code a way cleaner in the place when it matters. Okay, so I've got we came to the end, and to sum it up a bit, here's yours, Objective-C Army knife. I hope that you will use it maybe once or maybe twice. And the first was about collection, to use strongly typed collection wrappers backed by Java util collections instead of collections directly. And the really important thing is to remember about logic boundaries to avoid accidental duplication. And we are doing it to make our refactoring easier, make our code better named, and make our collections more objective, let's say. The second advice I give you, second tool in that Swiss Army knife is related to inheritance. And I I recommend to identify what is your type of inheritance, where is a change vector. So if we are thinking more about changing functions and adding functions, than about adding new subclasses. And then you know what your design should support. And then you can use a visitor pattern or that single point of implementation that will help you to not forget about any services or interfaces that you need to implement to provide some functionality. The third one was about untangling unrelated concept using null object, proxy, comment, and factor and decorator pattern. And the factor method will help you move that creation to single place. And you should consider that factor as a place. I consider it, and I think it's not so bad. You should consider it as a place to put a mess. Like everyone has in the house this room that if you need to make a fast cleanup, you're putting everywhere there and you're just closing the doors. So for me, the factory is such a place. I don't believe that code can have no conditional expressions, etc., etc. So I would rather to put them there than to see that tangling concepts that I don't know on what put my focus. And as with all advice, recipes that I gave you have their limitations, and to use them properly, you need to think critically. So anytime you think that you should use it because it's fun or it's great or you want to use it, don't use it. Use it only when you need it. When you see that you've gained something, like your code will be better, your code will be cleaner. It's the real purpose, and this is the moment when you should use it. Okay, so thank you for your patience, and thank you for listening.